So hi everyone, welcome to this webinar offered by Discover the Universe. My name is Julie, I am the director of this program, and for those of you who are online, thanks a lot for filling the poll. I see that over 50% of you actually are new to Discover the Universe. Hold on, I think, there you go, if you want to see the results. So many of you are new, so this is, I guess, a new event for you with Discover the Universe. I know some of you are repeat participants. I see many of you are from outside Canada, so this is very exciting. Welcome. We are a Canadian program, but it's always nice to have people from other countries as well. So yes, if you want to introduce yourself in the chat, for those of you who are live, then go ahead. This will be recorded, so many of you are probably watching the recording or will be watching the recording. And if you have to go, if you're live and you have to go, you will be able to go back and watch the rest of it if you are interested later. I see a quick question right away in the chat. So what grade level is this webinar for? I tend to keep it quite open. Like it's very hard to cover the whole solar system in 1 hour, right? So it's going to be just little bits in there that I've decided to cover because I think those points are interesting. And it's very hard for me to put a grade level in the sense that I've taught college physics in Quebec. So, you know, cégep, so students that were 17 years old and above. And I did have to give them some very basic knowledge about the solar system. So I think the content can adapt from elementary or high school, and even sort of astronomy 101 from university could probably benefit from some of this information. So I think it's more to you as a teacher, as the educator, to take whatever is relevant for your classrooms. But I think having more knowledge about the subject anyway is always good. So there you go. It's meant for teachers and educators. So you see our goal here, Discover the Universe. Our goal is to help you by providing you with educational resources and training in astronomy. And then hopefully you can use that in your classroom or whatever educational setting you work in. And so most of what we do is free and online. I mean, not only because of COVID, but we've been doing that for many years. We are based in Canada. We offer everything in English and French, but as I see in the chat and as I know from other programs we offer, we do reach people all across the world. So that's pretty exciting, and welcome to everyone. We are offered by astrophysicists across Canada, mostly the Dunlap Institute at University of Toronto, and also the Association of Astrophysicists across the country. Just a quick, I don't remember if I introduced myself. So I'm Julie, I'm the director of the program, but I'm also the one presenting this webinar today. As I mentioned, the webinar will be recorded, and you will also have access to the presentation document. So I'll provide it to you in both PowerPoint and PDF. So feel free to use it, to steal images from it. I've put the credits to all the images, and you can play with it, or you can reuse parts of it with your students or for you as a sort of backup information. And yes, I see the question, is this available in French? I did present this webinar in French yesterday. You can go to our website on the French site. You can still register for it, and you will have access to all of this in French as well. Okay, hold on. I'm just gonna stop this. Okay, so just to let you know as well about our next workshops, we have a webinar coming up in October about Mars, specifically about Mars, because it's pretty fascinating. It's going to be visible in the sky, very easy to see, and it's going to be in a position that's when it's closest to Earth, so we send probes. I'll tell you a bit about it today, but really if you want to learn more about this planet, come back and register for a workshop in October. And then we do have our workshop for teachers level 1, which is meant more for elementary school or middle schools. But depending on where you teach, what's your background level in astronomy, this would be very interesting information to get started with. So we'll show you, so to learn the night sky, how to use a program like Stellarium, which I'll show you today, basic information about Earth, Moon, Sun, so phases of the moon, eclipses, solar system, our place in the universe. So it's very sort of introduction to many concepts that are taught more in elementary and middle schools, but can be adapted to many other levels as well. So today I'm here to talk to you about the solar system. As I mentioned at first, it's a pretty wide topic. I won't cover everything, but I know from my experience going in classrooms, I often see that teachers, they don't know much about the solar system, and that's understandable because you don't have any formal training in astronomy. And usually we just cover the planets, and very often a project that I see a lot is to get students to research a planet. This is great, but there's a lot more that we could do, and there's a lot more to that. So that's what I'm going to start with today. If you have questions at any time, feel free to write them in the chat. I'm getting pretty good at watching the chat from the corner of my eye while presenting. And if you are watching the recording, feel free to email me. My job is to help you in astronomy, so you can email me afterwards. Okay, so what is the solar system? Well, the solar system is made up of all matter which is gravitationally bound to the sun. Any object in orbit around the sun is part of the solar system. And I like to mention that because it includes much more than the planets. I've often seen people describe, and I guess it's a good way to simplify it, saying solar system, it's the sun with the planets. But then it kind of makes you wonder about the other objects. And for example, why I bring this point is that I've gone to classrooms where kids would ask me, why is Pluto not in the solar system anymore? For them, the solar system was sun plus planets. So if Pluto is not a planet anymore, it's not part of the solar system. And I realized that a lot of it is due to how we teach the solar system. So yes, sun and planets are the biggest objects, but there's a lot more. And it's not because they're not planets that they're not interesting. And I hope this is a takeaway you get from this webinar, is that some of the most interesting objects in the solar system are actually not planets. So I'll show you some of them as we go along. And in fact, if you want to learn about many of the objects in the solar system, here's an activity which I got inspired. It's adapted from an activity by the Astronomical Society of the Pacific and the Pacific Science Center. I put the link there, and you will get, again, you don't need to copy the link right now. I will send you the PowerPoint, so you will have access to that link. I love this activity because you start with 28 cards, and there are many different objects in there. Some of them you've probably never heard about before. And just for students, for kids to look at those images and be sort of in awe of all the different objects that we see there is already very interesting, because it allows you to discover many new objects. And the goal is to have students create categories. How do you classify these objects? Of course, they'll probably put all the planets right away in the pile because they know about planets. But even there, the goal would be just imagine you don't know anything about these objects. What you know is what's in here. You know what the object looks like, the best picture that we have. And some of them, like Sedna here, they don't look very good because it's an object very far away in the solar system. You know its size, you know the distance to the sun. And for those of you who are less familiar, astronomical unit, that is AU is astronomical unit. And by definition, astronomical unit is it's the distance between the Earth and the sun. So Pluto is about 40 times further away from the sun than we are. That's it's a way to measure in the solar system. So you know how far it is to the sun, you know what it's made of, and you know it's in orbit around which object. And then you need to classify them. The younger kids will probably put them by color, by size, and then what's in the orbit around, and like there are different ways to categorize it, and it's very rich. I've done it with young kids and older people, and it's actually there's a lot to be learned there, and just looking at all these objects is actually very interesting. Yes, the cards, and actually in the PDF there you have the description and the link. I'm just curious, can you click on the link within Zoom? Okay. But no worries, I'll send you, thank you everyone for answering. I'll send you the PowerPoint so you will have it. Actually, hold on, no, I can't do it myself either. Okay, so this is an activity I really like and I encourage you to do. So the sorting solar system. And this fall, go outside and observe the planets, or encourage your students to do it. This is gonna be a very good time to view the 4 brightest planets, Jupiter, Saturn, Mars, and Venus. They happen to be visible this fall. I know this is not something you can do in class, but this is not something that will be visible only one evening. So you can have them and remind them, hey, go outside, this week, try to see it tonight or maybe next week. And it can be done over a longer period. So maybe they'll think about looking up a lot. And for those of you who are familiar with my programs, I invite you to observe the sky a lot. Just think about looking up and pay attention to what you see. Some planets are easily visible even in the city, depending on how tall the buildings are in front, around you. But it's not something, you know, it's something that's accessible to everyone, not just people in a rural area where there's less light pollution. I see a question there about the distance from the sun. And I see the question from Lauren, sort of, could we update the cards to display average distance and mean and max? It could be. We just decided to keep the information quite simple. So distance from the sun is sort of, you know, the minimum, well, the average distance from the sun, but it varies. Some objects, it will vary a lot. I think some of them might have different values. Yes, some of them will say from that distance to the other distance because it has a very elongated orbit. But yeah, it could be, if you wanted to do that, you could even update your cards yourself. Okay, so let's come back to observe the planets. So I don't know if some of you have seen them before. So far this summer, Jupiter and Saturn have been visible all summer. So if you have seen them, you can just let me know in the chat. And yes, Spencer, the cards are available in French. Again, you can email me and I'll send you the information or go on the website of our website, French side of our website. So yes, if you have seen Jupiter and Saturn, they're beautiful. So Jupiter is very bright and it will be sort of the first star, the first point of light to appear in the southern part of the sky after sunset. And it will be visible all fall until later in November. So if you look south after sunset, this is sort of early September sky around 8:15 p.m. Jupiter very bright, Saturn bright, but not as bright to the left of Jupiter. So it's very easy to looking in, you know, just looking in that area of the sky, you will see them. You don't need a telescope for this. I always want to emphasize that there's some very interesting things to see with just the naked eye. Of course, if you have binoculars and, you know, maybe you've never pointed them to the sky before, try it. For Jupiter, you can see the disk of Jupiter and maybe its 4 brightest moons, largest moons around the circle of Jupiter, which is pretty neat to observe. But just with the eye, you can see the point, you know, Jupiter and Saturn quite well. Mars, if it currently rises around 9:30, but it will be visible right after sunset in a few weeks. So right now it might be late for many students, but in a few weeks it will be visible right after sunset. It will be very easy to see. It's, again, very bright, so it stands out. It's not like you have to guess which one it is. It stands out in the east, and it has an orange hue to it. So this is right now in the east, and it will be in a position on October 13. That means it's going to be on the same size, same side as the Earth around the sun. So it's opposite, from our perspective, it's opposite to the sun. That's why we call it opposition. And it means it's the closest to the Earth. It's the best time to observe. And this is an alignment that repeats every 26 months. So this fall is going to be great to observe Mars, but then after that, it's going to be like, it's going to be nice to observe for a few months. And then after that, it's going to be 26 months, over 2 years before we can see it as well. And I created a little video here. This is the images I'm showing you, I created in Stellarium. It's an amazing planetarium software, and I'll show you the links in a minute. So I created this short video, so it shows you the sky on, I'll point here, on September 3rd at 22, so 10 p.m. This is, again, from Canada. I see many of you are in other countries. This is from Southern Canada, but you would have to adjust and see what it would look like from where you're located, because Canada is pretty far north. So this is about for a latitude of 45 degrees north. It might be different where you are. You would actually see them better, see the planets better, because they would be higher in the sky. For us, they're lower. But anyway, on September the 3rd, you can see the moon here is not so far from Mars. And I will play with the settings. So I created this short animation here to show you a bit how the moon will change every day. So I'm increasing day by day. So at 10 p.m. every night, then go from the 3rd to the 4th, the 5th, 6th, and 7th of September. So you can see how the moon moves in the sky. And I just came back to the 5th because on September 5th, the moon will be right next to Mars. In some parts of the world, it might be over it, actually. So again, you will need to check. But this is pretty neat. So you can check it out in a week or so, and you can see Mars next to the moon. This is around at 10 p.m. So it's more for you and for your students, depending on their age. But it's kind of fun to see things like that. It will happen again in a month. The moon will come back to close to Mars as well. So if you're looking, for example, mid-October around 8 p.m., so a pretty decent time, because it gets darker earlier, at least for us, again, in the Northern Hemisphere, we will have Saturn and Jupiter in the south, southwest, and then Mars very bright in the southeast. So it will be very easy to observe these planets, and they will be there for many weeks. So again, it's not just something, tell your students like, watch tonight. If it doesn't happen, that's it. No, they could watch it over many weeks. And if you wake up very early, you can see Venus early in the morning before sunrise. It's already there. So if you happen to wake up around 5 in the morning, you can see it. So if you look in the east, early morning, September sky around 5 a.m., you can see Venus. It's super bright. It doesn't look that much like that way here on the drawing, in the sense that it seems even fainter than Sirius, but Sirius is the brightest star in the night sky. So I mean, the brightest star in our sky is the sun, but at night it's Sirius, and Venus is quite bright compared to Sirius even. So it will be the first point of light you see there. So if you happen to wake up before sunrise, look in the east and you will see Venus. So there you go. You have the 4 brightest planets visible this fall. It might be a good time to encourage your students to look up, and even yourself, if you have never done that really, or paid attention to the sky, then go outside and have a look. Just 5 minutes, sometimes you can see them. So the images I created were done with Stellarium, which is a planetarium software that can show you the sky at any time and anywhere on the planet. There's a web version, which is probably the easiest for many teachers, in the sense that there's no setup required, especially for computers or iPads, for example, that your students might have access to. It's in English only, while the downloadable version can have multiple languages, but they're both free, so they're great. The images I created were done with the downloadable version, and we put here the English Canada because it's a bit different, but you have like regular English or other languages as well. And you can also have it as a mobile app. And what's very interesting, it costs a few dollars though, but it can show the sky in the direction where your device points. So you go outside, you hold your cell phone, for example, and it will, in the direction, and it will identify what you're looking at in that direction because of all the sensors that it has. So this is a pretty good use of technology, and it's a lot of fun. If you do, there are many other planetarium apps that people use, Sky Safari, Star Walk. If you know some of them, feel free to type them in the chat for other people to check as well. Okay, so I told you about how to observe some of the planets this fall, but the solar system, like I said, is a lot more than just the sun and the planets. Actually, our solar system is composed of 1 star, our sun, 8 planets, 5, but probably a lot more dwarf planets. I'll come back to all that in a sec. Hundreds of natural satellites or moons, millions or billions of small bodies, and I threw them all together, whether they're asteroids or comets or trans-Neptunian objects. This might be a new term for many of you, I'll explain. And there are countless small debris called meteoroids in orbit around the sun. Any small rock or sort of sand or dust, there's a lot of dust, a lot of those in orbit around the sun as well. So at the center of our solar system is a star, our sun. We won't go into all the details for stars. I don't have that time to do that, but basically it's a big ball of gas that glows. It generates its own energy and heat from the nuclear fusion happening in its core. So a difference between a star and a planet would be, for example, that the sun emits a lot. A star, or the sun, same types of objects, they emit their own heat and their own light, and they are quite bright. We can see them across huge distances in the sky. So this is something interesting, especially for younger kids, for them to understand that stars and the sun, the same types of objects. It's not that obvious when you start, because obviously you see the sun during the day, it's much brighter, it's hot, and we can see it better, but it's the same type of objects. And one thing that's interesting as well for little kids, to have them realize that a star is actually a sphere. It's not star-shaped. It sounds basic, but it's true. We draw stars like this, but in reality, stars are spheres. They're a big ball of gas. So, it's interesting to have them realize that as well. And it's very big. I don't know if you saw it appear, right here is a blue dot. I put it roughly, but it's roughly the size of the Earth. I think actually the Earth would be even smaller than this. But, just to get an idea of how big the sun is. And there are stars that are even larger than our sun. So we're pretty small. The largest spherical objects in orbit around the sun are the 8 planets. So you have them all here: Mercury, Venus, Earth, and Mars, which are the small rocky or terrestrial planets closer to the sun. And we have Jupiter, Saturn, Uranus, and Neptune, which are gas giants. We sometimes call Uranus and Neptune ice giants because their composition is a bit different. But especially if you're starting or teaching solar system at the basic level, gas giants is good, especially because we're talking about the surface. Like, we could land on Mercury and Venus, Earth, and Mars. There's a solid surface. We could hit our foot on the ground. We wouldn't be able to do that on the other 4, Jupiter, Saturn, Uranus, and Neptune. We would go through the gas, sort of go inside the planet, go deeper and deeper. At some point, the pressure would crush us. We wouldn't be able to go through. But what we see is actually the gas. And it's just not just like, on Earth is a thin atmosphere. Venus as well, there's a thin atmosphere. We're talking about a lot of gas very, very deep here for the gas giants. The picture you see here is not quite to scale, but it does show you that Jupiter and Saturn are much larger than Uranus and Neptune, which are also much larger than the other 4 right here. Now we have dwarf planets, and this is a new category that was added in 2006. And for many of you, I know for myself, this was 14 years ago, but we grew up learning that there were 9 planets. So it was a bit confusing at first to understand the transition. And I realized that many kids, even if there were, if Pluto has been a dwarf planet for all their life, they still sort of understand this. They're still confused a bit about this. Basically, dwarf planets, it's a new category, and it includes spherical objects in orbit around the sun, but which are located either in the asteroid belt or the Kuiper belt. And the Kuiper belt, I'll come back, I have another slide about it, but basically it's like a second asteroid belt very far in the solar system. So if it's not alone in its orbit, like, Jupiter has many moons, but it's the dominant object in its orbit. Then it's called, if it's part of a belt, basically, it's called a dwarf planet. So there are 5 of them right now officially recognized as dwarf planets, but there are hundreds of objects that could fit in this category. And we know of hundreds of objects, for example, in the Kuiper belt. We don't know yet if they're spherical. And this is why we can't call them dwarf planets. There's just points of light. They're so far away, we just see them as points of light, and we don't know if they're spherical, so we can't officially call them dwarf planets in that case. You can see here, Pluto is quite small compared to the Earth. This is real size, sort of to scale, sorry. Ceres as well is quite small, but it is spherical, so it's a dwarf planet. And Aries, this is an artist impression, it's not a real picture, is an object we found in the early 2000s in the Kuiper belt, and we realized it was about the same size as Pluto. So that's the object that kind of brought this whole discussion of what do we do with Eris? Do we call it the 10th planet, or do we create a new category? And that's how it ended up, dwarf planets. But something that you'll hear me say a few times in this presentation, it's not because it's not a planet that it's not interesting. Or basically, there are many objects that are not planets which are very, very interesting. Oh, sorry, I'm having issues with my mouse. I'll go this way. So what is the Kuiper belt? This is the region beyond Neptune's orbit, with numerous small objects. So about the size of Pluto, smaller. No, we're not talking about big planets here. They're relatively small, but still many, it can be many hundreds of kilometers across. And you can think of it as a second asteroid belt, but much wider and composed of icy bodies. We tend to say asteroids are rocky objects, trans-Neptunian objects. So those objects are beyond the orbit of Neptune in the Kuiper belt and beyond. Then those are they have a lot of ice in them, just like Pluto, for example. And Pluto is one of the largest known objects located in this region. This is an image taken from this video. So I'll invite you to go check the video because it shows you the points which each represent a real Kuiper belt object as time goes by, so when it was discovered. And you'll see that the video starts, I think, in 1995. We knew Pluto and maybe a few others, and then you'll see as time goes and we discover more and more of them. And this one here is Eris, that was discovered in 2003, I believe. But this is why a lot of school material does not mention the Kuiper belts, because it's relatively new. This is something that happened in the last 20 years that we've realized that there's this whole other region in the outer solar system that has many objects because they're quite small and so far away, we can't see them super well. And, you know, I like to mention Canadian expertise because we, you know, it's not known enough. Canada is really doing super well in astronomy research, and I feel like many Canadians don't know about it. So actually, there's this team from Victoria and Vancouver that have done a lot of the studies on the Kuiper Belt, and I've heard, anyway, last time I talked to one of them, he said that about half of the trans-Neptunian objects were discovered by Canadians. So there was a big project done mostly using the Canada-France-Hawaii telescope in Hawaii, and they've discovered many of those objects. But it didn't really go in the news because it was not like a big object, but still it's pretty interesting. I see a question here, are they water ice or other forms of ice? Different types of ice. So you're right, there's water ice. And usually when we say ice, we mean water ice, but there's methane ice, there's carbon dioxide ice, ammonia ice. So there's different types of ice that we do find on these bodies. If we look now at even smaller objects, some of them would be in the Kuiper Belt, so we would call them trans-Neptunian objects, but the ones that we see mostly in the inner solar system, the asteroids, they're rocky objects with irregular shapes, and they're smaller than dwarf planets. So if it's an object that's small enough so that they're not spherical, then you know, that's what we call an asteroid. So you can see them here. They're sort of large space rocks. Some of them are just a few meters or hundreds of meters across. Other ones are hundreds of kilometers across. When they reach about, it's on the order of 600 kilometers or maybe more, depending on the types of objects, material that they're made of. But around that range, that's when they could start being spherical, because their own gravity will sort of press them and smoothen them to make them spherical. But below many hundreds of kilometers, then they're just random shape. There are probably millions in our solar system, mostly located in the asteroid belt. Sorry, not belts, but belt, I'll correct that. But it's, you can find some on other orbits as well, but most of them are located in the main asteroid belt between Mars and Jupiter. So Lawrence, just to confirm that the trans-Neptunian objects are mostly water ice. No, there are actually other forms of ice as well. I don't know like the exact proportion, but there's water ice, but all the other ones like methane and ammonia and so on. So there's all of those. In fact, Pluto, I think, has the surface is mostly nitrogen ice, if I remember right. There you go. There's different types of ice in those objects very far in the solar system. Oh, and yes, I did put a link there. So again, you'll have the PowerPoint. So I've added a few links there, because if you're talking about asteroids to your students, you might not know like the latest, you know, the sort of probes that have been going to study them. But there's a Japanese probe that landed on an asteroid last year, and you can check it there. It's pretty interesting to see the surface from an asteroid up close. I won't put all links to all the probes because there's been a lot, but I'll highlight a few in a few minutes. Now, if we talk about comets, those are small icy objects. So again, they have a lot of ice, all the kinds of ices that we just talked about. But what's interesting with comets is that the name really comes from how we see them in the sky. When we visit them, and this is a comet Churyumov-Gerasimenko that was visited a few years ago by an European probe, and you can see the core of it, the nucleus there, and it looks a bit like an asteroid, like the pictures before. But there's a lot of ice in there. So when it gets close to the sun, the ice turns to gas and it reflects sunlight and it creates a tail, and that's what we see. So you can see a bit here of the haze there from the ice turning to gas. But this is how it looks in our sky. And this is not, I like this picture because it shows what I personally saw this summer. I don't know if some of you got to see Comet Neowise this summer in the sky. Again, let me know in the chat if you did. It's quite rare that we see a naked eye comet, so a comet that we can see in the sky just with our eyes. It was faint. I live in a rural area and I could see it with my eyes, but when I went to a city, when I went to Sherbrooke, I couldn't see it. So if you live in a big city, unfortunately, you probably missed out. But you can see how it looked here compared to the Big Dipper. That's why I like this picture, because it really gives us a look of how it looked in the sky when we saw it. And the word comet actually means a hairy star, and that's what it looks like. You know, it's a hairy star, basically. that we see. But I like to mention that the tail that we see is not fire. And in so many cartoons, and I think in The Simpsons, when Bart discovers a planet or a comet or something like that, it's been a while since I saw it, but you see the comet as fire basically going through the sky pretty quickly, like in a few hours. That's not how comets work. Comets are not fire at all. They are big dirty snowballs basically, and they do move in the solar system, but it takes a few weeks for them to move across our sky and not be visible anymore. So this one actually took a few weeks, and then it was too faint for us to see with the naked eye. But still, it's very interesting to see in the sky. It was beautiful, but again, unfortunately with light pollution, many people missed out on this show. Speaking of this one here, Comet Chury here, there's a series of video that was created by the European Space Agency, and I love them. The adventures, once upon a time, the adventures of Rosetta and Philae, the lander, and they're cartoon based, and they're just very well done. They explain the science in a very nice way, so check them out. I highly recommend checking those. So now if we look at another type of objects, we have natural satellites or moons. And what are those? Well, they can be any shape, any size, but basically it just means that they don't orbit the sun directly. They are in orbit around something else that is in orbit around the sun. And that something else could be a planet, could be a dwarf planet, could be an asteroid. Some asteroids have moons. So sometimes we simplify and we say, what is a moon? Well, a moon is something that goes around a planet. Well, it could also be, the moon is something that goes around a dwarf planet or an asteroid. It's sort of the second level of orbits. There are hundreds known moons in the solar system. I personally don't remember the number, like how many moons does Jupiter have or Saturn have, because it changes regularly. Like you can go online, and Wikipedia is a very good source for that in astronomy. You can go and check the latest numbers. But now we know of hundreds of them, but there are probably more. And in fact, there's a limit. At some point, if we do find a rock size, like this big around a planet, do we call it a moon? In fact, Saturn's rings could be considered as billions of small moons because they're chunks of ice. So it depends. Again, the limits between these categories can be discussed a lot, and that's what I find interesting. In fact, when I say, just coming back here, in the last few years, when there were discussions more and more about objects in the Kuiper belt, for example, Pluto is made mostly of ice. If Pluto was on a very elongated orbit and came close to the sun, it would turn into a comet. It would have this long tail because the ice would sublimate and become gas and would have a huge tail. So Pluto, we never call it a comet because it's far in the solar system and it never gets close to the sun. But if its orbit was different and it had very elongated orbit and came close to us, it would turn into a beautiful comet in the sky. So these definitions, very often they're historical, like the way we discover these objects, but then we have to think of them as like they adapt, and our knowledge changes, and that's how the science works. We discover new things, we need to adapt our definition, and that's just what happened with Pluto not being a planet anymore, but a dwarf planet. But one thing I want to say about moons, and I'll come back to some of them, is that they are very interesting objects. Many are spherical. That means they're big enough to be spheres, and 2 of them are actually larger than the planet Mercury. Ganymede here, the largest moon around Jupiter, and Titan, largest moon around Saturn, they're both larger than Mercury. So if you're new to astronomy and didn't know about Titan and Ganymede, well, that's normal because most people don't. But if these objects were in orbit directly around the sun, they would be called planets and everybody would know about them. So it's very interesting on where we put the emphasis as educators. Do we only want to talk about planets, or do we want to talk about some of the most interesting objects in the solar system? And in fact, I love this image from the Planetary Society, the nut planets. So the spherical objects, which have been visited by spacecraft, so we have nice pictures, but they're not planets. But in fact, if you show this to kids without the nut planets title, and if you ask them what they were, they would probably say planets because they look like planets. And again, these are pretty big. These are larger than Mercury. You can see our moon there, Pluto, and its largest moon, Charon. Some are asteroids. So Ceres is part of the asteroid belt. It was for a long time considered an asteroid. Now it also has the dwarf planet title because it's a sphere. But we'll talk about some of these moons in more detail in a few minutes because they're very interesting. So yeah, exactly. So somehow some often forgotten objects are very interesting. And I think that, you know, we should just talk about them more. So Titan, Saturn's largest moon and the second largest moon in the solar system, is the only moon that has a dense atmosphere. So it's mostly composed of nitrogen, but it has a thick atmosphere. That's interesting. Like it's, you know, it's the only moon that has an atmosphere, and it has things happening at the surface that are very interesting. It has liquid on the surface. Because it has an atmosphere, it can contain liquids. And the liquid there is actually mostly methane, which is natural gas. So there are lakes of natural gas, of methane on the surface of Titan. And we think it rains methane. So it has sort of this cycle, instead of the water cycle, it has a methane cycle. And there might even be an ocean of water under the surface. This, again, is from the latest research in the last few years. We found that many objects very far away in the solar system, they could have water like H2O, an ocean under the surface where it would be liquid. So there's a lot of ice, but there could also be liquid under the surface. And that's very, very interesting. Looking for ocean worlds is sort of the best way to look for life somewhere else in the solar system, because life as we know it needs liquid water. So as we learn about these objects that might have water on the surface, liquid water, then it's very interesting because there could be primitive life there. You know, that would be very, that's the question is there possible life there? Well, we don't have a proof, but if there is liquid water, and you'll see many objects I'll show you, the latest sort of research shows that there might be liquid water under the surface. It's impossible for us to know. We don't necessarily think there could be some very advanced civilizations underneath the surface, but could you have very simple life, unicellular organisms? We don't know, but if we knew that even one cell exists somewhere else in the solar system, it means that life has evolved on two objects just within our solar system. So then the chances of life somewhere else are much higher. So that's why there's a lot of research being done even within our solar system. And up to a few years ago, we were mostly concentrating that research on, focusing that research on Mars, because Mars, you know, is probably one of the best places in the solar system to know where, you know, could there have been life in the past, for example. But now that we think about all those objects very far away that could have liquid water, then there's more sort of interest towards those as well. So there was a probe sent to the surface, the Huygens probe, which was part of the Cassini, the Huygens lander part of the Cassini probe, and it landed on Titan. So the picture you see there on the left is an actual real image from the surface of Titan. You can see a hazy sky, you know, but you can see rocks. And actually, those I think are mostly ice, sort of chunks of ice on the surface. And on the right there, you can see a radar image from Cassini, and it shows a methane sea. So we think that's actually sea-aware liquid on the surface. And you can see how it changes over time as well. So it's like there's a part of an island that appears, you know, instead of the water level, and it's the methane level, and it shows different parts there. So that's all pretty interesting. And some artists created a representation of Titan's surface. Again, this is an artist representation, but it kind of shows you what, you know, maybe you could see if you were standing there with that lake or sea in front of you. And I put the link there so you can go and click. Yeah, I don't think you can walk around Titan, but on that spot, you can have a look around, and just to, you know, to highlight that, it's pretty interesting for students to imagine what it would be like to stand there. What would you see? And I think there, if you want to mix arts with science, this is a very interesting way to do it. Just imagine what you would see if you were on Titan or on Ganymede or other moons, for example. Now let's talk a bit about Pluto. Pluto is one of my favorite objects in the solar system. And again, even though it doesn't have the planet status anymore, it's worth talking about. It's fascinating, and I was personally blown away with the results from New Horizons in 2015. That was the first time we saw Pluto up close, and it was very different than what I expected. And I know many scientists were also very surprised because it was, there was some geologic activity. We didn't think the planet, this planet or this world was geologically active anymore. It's so small, so far away in the solar system. I personally expected something like the moon, you know, body with lots of craters, an old surface, not so much happening. But turns out it's still active. It has a lot of a very diverse surface from what we can see. And it could even have a water ocean under the surface. So again, a liquid water ocean under the surface of Pluto. That just blows my mind. You can see here the varied terrain. When you look at the surface, actually, if I come back here, this is sort of the heart on Pluto. And this part here, this is an icy plain. This is what we see here. So this is half of the heart. This is an icy plain. And you can see some darker regions here with many craters. But you can see that it looks like the ice kind of sometimes bubbles from this underneath. And it comes here and it fills some of those craters. So there's some stuff happening there. And I believe it's still being studied exactly what could be happening there. We can see some icy mountains. These are water ice mountains up to over 3 kilometers high. So that's pretty neat to see on the surface of an object so far away. And by the way, the New Horizons probe didn't stop at Pluto. It just flew by very quickly. It didn't stay in orbit. It didn't land. It just flew by. That's all we could do. We didn't have enough fuel to slow it down. Because once you give the probe a very high speed to get there, it would take a lot of energy to slow it down. Otherwise, it just keeps going. So for a few days, as it was getting close to Pluto, it took many, many, many pictures. And then it downloaded them all to Earth over the course of a year. And then we got to see all those amazing landscapes. This is my favorite image of Pluto. I just love it. This is, as the probe was a bit on the other side. So you can see sort of the non-lit part here. The night part of Pluto would be here. This is the sort of day part. But you can see the shadows here of those mountains, and you can see the plain of ice. I love this panorama. I think it's very, very beautiful. As you might have noticed in the PowerPoint, I put the credits for all images, and I tried to put links on where I took this image. So if you want to learn more about a specific image, you can go on that link and try to get more information. I want to mention Enceladus, which is another one of Saturn's moon. It's a very small moon. Actually, hold on. I'm gonna come. No, I'll do it this way. It's gonna be faster. Sorry, if I come back here, I'm gonna talk to you. So we talked about Titan, about Pluto, which is a bit smaller. I'm gonna talk about Europa and Ganymede and Callisto, but look at Enceladus is a small one. It's a very small moon around Saturn, very far away in the solar system. So we didn't expect anything like this. Look at the surface, a lot of ice, and actually you can see cracks on there. So there's something interesting happening. But the Cassini probe, which visited the Saturn system for many years, took pictures of what looked like geysers. So there's basically liquid water coming out from underneath the surface. So Enceladus is now one of the best places to look for liquid water far away in the solar system, because we have pretty good proof that there is a possible liquid ocean under the surface. So it's a very interesting world, and we didn't expect that from such a small world, a small object in the solar system. So yes, it's very icy. I didn't put any in the PowerPoint, but if you go online for sort of Enceladus interior, you can sort of a cutout on what we think the interior would be like. Very often it would have a rocky core, and then it would have a layer of ocean of liquid water, and then there's ice on the surface. And once in a while you would get those geysers, and they're sending out new material from the interior to the surface. So Enceladus is very interesting. Same with Europa. For a long time, I only talked about Europa as a possible icy moon with a liquid water ocean underneath the surface. This one is larger, and also it's icy, and you can see some cracks and sort of new things happening from the interior. But now Europa is not alone with this idea of liquid ocean under the surface. Enceladus is a very good candidate. Pluto, Titan, Ganymede, and Callisto as well, 2 other moons of Jupiter. All of these seem to have a liquid ocean under the surface, which is very, very interesting. These are not to scale. I just put Europa larger because I think it's more fascinating in the sense it's been known for longer, that it has a very icy surface and then liquid water underneath. We have pretty good results showing that. But the other, Jupiter has, I believe now the count is 79 moons, but it has 4 largest moons, the ones you can see with a telescope or small telescope or even binoculars. So the other 3 are these. And the 4th one is Io, which is completely different. It's actually one of the objects in the solar system with the least water, H2O on it. But it is the most geologically active object in the solar system. It has over 400 active volcanoes. And that's pretty interesting as well. So it's quite different than the other ones. When I say ocean under the surface, yes, I mean H2O or water. So I try to, I probably don't say it all the time, but yes, I really mean water as we know it. And that's why it's interesting, because that's a condition for life as we know it. So there are many topics of discussion that you could have there with your students. I mean, I think the basic, if you wanted to have your students research like in groups like each a planet, at least include other objects, include some moons in there, because some of them are so fascinating. I personally find the ones I just told you about much more interesting than Mercury. There's a lot more to say, for example. And even the numbers, like how long it takes for it to rotate and its inclination and so on, those are interesting details, especially to understand the differences and how things work. Just understanding the variety of objects in the solar system, it's great to compare all of them like that. But you know, you could ask your students, like if you could send a probe anywhere in the solar system, where would you send it and why? And depending on what your probe wants to discover, like if you're looking for life in the solar system, considering that life as we know it requires liquid water, where would be the best place to look? And I like, you know, we sometimes talk about life on other planets, but you could even start with your students with that question, like, could life exist on moons or dwarf planets? And, you know, at first, if you start your astronomy unit with that question, they might say, well, no. But maybe after you've shown many moons, then it was like, of course, you know, if those are some of the best places to look for life in the solar system. I want to talk to you about some of the latest space probes. There are lots of probes, active probes in the solar system. So I put a link there. This is just a Wikipedia page, but it lists many of them. And I don't even know all of them. So don't expect to know all of them either. But some of them I find very interesting. And I wanted to highlight some of their latest images. Because again, if you don't follow the news about the solar system, you might not know about these probes that are, you know, active now and taking amazing pictures. So if you want to talk about Jupiter, make sure you include some images from Juno. It's been in orbit around Jupiter since 2016, and it has a very elliptical orbit, so very elongated orbit. You can see here it gets close to Jupiter and it goes far away, and it gets close again and goes far away. And it does that every 53 days. And it also goes above the poles. So this is an artist rendition of the probe. Oh, by the way, it is solar powered. This is interesting. It's the furthest probe that we've sent that uses solar, the sun as its energy, because it's quite far when you get to Jupiter. That's why it needs such long solar panels to get all the energy that it needs. But yeah, so the probe goes above the poles, which gives us different views of Jupiter than what we're used to. So the image you see in the background, this is, you know, what we see from Earth, or with, well, pretty much from Earth, not quite, because we don't see all of it. But what we've seen before with probes, and from Earth, we see the cloud bands right here, and this huge storm, the Great Red Spot on Jupiter. But we get to see different things with Juno, and check it out. The pictures are just amazing. So you can see with the surface with all the, I mean, these are clouds that we're looking at, right? So there are storms. You can see many of those storms there. And as we get close to the poles, the vortex are just weird. It just gets all mixed up. It's not all those horizontal bands anymore. You know, like this here. I like that one. It looks weird. And this is where, you know, science and arts pretty much get mixed up. Look at this on the left. It looks almost like a painting. And you can see some of the clouds here. You know, it shows that these are higher because you can see the shadow here. You can see huge sort of hurricane here. And this is another storm that's, I believe this one is a few 1,000 kilometers across. So these are storms, you know, cyclones, but on a larger scale than we see on Earth, like tens or even 100 times larger than what we see on Earth. And the probe gets so close to Jupiter, actually, we can see details pretty amazing. Like this one here, again, beautiful vortex with some clouds, and it's just, I love the details that we get to see with Juno. I'd never seen Jupiter like that, and it's just so beautiful. And here's a great red spot. I love that cyclone and that storm. I like to see it move like that. It's pretty beautiful. This is, of course, a loop, but still pretty interesting to see those clouds move in there. This is a storm that has been on Jupiter for at least 400 years. Galileo was the first one to observe it 400 years ago, and it's still there. So it's pretty amazing. You know, sometimes we complain about weather on Earth. It's not that bad compared to other planets. And actually, hold on, I forgot to mention that. I'll come back here. So every time the probe gets close to Jupiter, that's what we call it perigove, so the closest point to Jupiter. And it gets extremely close, like on the scale here, it would pass like pretty much here, and then it goes far away again. And I'll show you this video. It's really like Jupiter, like you've never seen it before. And every perigove, Juno takes some pictures, and it's pretty interesting because there are people all around the world that take those pictures and they make those movies. So they're not really made by the Juno team. Juno probe takes the pictures, and then people around the world combine them and create pictures. So this is the link that you'll get. I'm including it here in the PowerPoint, but as you get it, you'll have to go and check it online. But here, I'll just stay quiet for a minute because it has music. Hold on, I just want to make sure. Okay, there we go. You probably understand why I wanted to show it to you. It's such a beautiful video, and of course the music adds to it. But like someone mentioned, it does look like Van Gogh, and I look at this view of Jupiter. I had never seen it like that before because we always see the side from Earth, and I think it just gives us a very different view of the planet and just how beautiful it is. And this is something that I like about the solar system, is that the variety of surfaces that we see, they're so different, but they're very, very beautiful. So hopefully you get to show some of these to your students. And if you hear, or if you see in the news, like new perigove video from Juno, it means that, 53 days later, when Juno went by Jupiter again, it took many pictures and people have combined them, because there's quite a few of those online, actually. Okay, hold on, I need to. Okay, so if you want more information on Juno, I'm including some links there. Again, if you join late, the PowerPoint will be provided. The Wikipedia page, again, in astronomy, I find Wikipedia super reliable. So it's always a good place to go if you want some facts, for more information about a planet or a probe. And APOD here, if you're not familiar with it, it's a website that's used a lot in astronomy or astronomy education, or astronomy picture of the day. So every day for the last 20 years or so, they've been putting a new image. And sometimes I go there because they basically highlight some of the best pictures that we see of the universe. So if you do a search for Juno or Jupiter, you'll probably see, that's where I found this perigove video. Actually, I went there, I looked for Juno, found a perigove video. Sometimes they're videos, sometimes they're just pictures, but it's a great way to search if you're looking for a very beautiful image on one object. Go there. I see, I'm not sure about the ears comments, so I'm sorry, Lawrence, maybe you might want to explain that a bit better. But the other one, what is casting shadow on Jupiter? What I mentioned earlier were some of the clouds that were casting shadows sort of behind. That was on one of the pictures. Like this one here, we can see this cloud seem to be higher, like higher altitude, so it's casting shadow here. sometimes we see some of the moons of Jupiter casting shadows on Jupiter, so basically creating a solar eclipse on Jupiter. I don't think we saw any of those in what I just showed you, but sometimes we do see that as well. I want to talk about Mars probes very quickly. I just see the time go, and I have very little time left. I might go over the hour a little bit. Hold on. Okay, I see the question. As Julo left, actually, it's just that if I come here, can I just go there? Here, this is just, oh, come on, stay there. Well, this is daytime on Jupiter. This is nighttime, so we're just above it, and we see one part that's lit and one part that's not. So that's just like on Earth. If you could see Earth from above, one part would be lit and one part would be in the dark. I'm guessing that's what you're asking. So I didn't see any other shadows, but that's a very good point. Thanks for asking. So I'm glad that that's what it was. It was obvious to me, but because I've seen it many times, but I understand it might not be obvious for people who sort of never took the time to visualize it in 3D. So thank you for the question. Okay, so Mars probes, there are many of them right now that are studying Mars. There's some from NASA, from the United States, from ESA, the European Space Agency. There's one from India right now. And there are many on their way there. I think this is maybe the first time we have 3 probes on the way, and there was a 4th one planned from Europe, I believe, if I remember right, and it got delayed until the next opposition in 26 months. But right now there's a probe from NASA, that's going to be a rover. There's one from China, and the first one from the United Arab Emirates that is going there. So probes are sent pretty much every 26 months now when both planets are close to one another. So just so you can see a bit how this works, this was when the NASA probe was sent. So that was earlier in July, I believe. So the Earth was here, Mars was here. Now the Earth is sort of catching up, and Mars, so the 2 of them might be, you know, one next to another like that in October, maybe more like here, I don't remember exactly. And then, yeah, probably more like here. And then when the probe arrives, Mars would be here and Earth will be there, but it's still the shortest path to make it to Mars when they're both on the same side of the sun. So now many countries are trying to reach Mars, as you can see, and there are many probes. And one that we've heard about in the last few years is the Curiosity rover from NASA. This is the rover on the surface of Mars. It actually kind of took a selfie from its arm, but they stitched the images together, so we sort of don't see the arm that's taking the picture, but it's pretty fun to see the surface, and it looks very, almost Earth-like. It looks like a desert on Earth, and it's been exploring the surface of Mars since August 2012. So it's been there for 8 years. And I like that, you might have heard about other rovers on Mars. There's been 3 generations of rovers so far. Pathfinder in 1997, and that's the one we see in the movie The Martian. I really like that movie, by the way. It was very well done. We see, the main character finds Pathfinder at some point buried in the sand. Spirit and Opportunity, 2 rovers that were sent in 2004, and then Curiosity, which arrived there in 2012. You can see it's much bigger compared to the people here. It's, it's like a small car, but that's very interesting to compare them. And this is one of the best picture of Mars. It looks kind of weird like that, but I put the link and go check it out. It's because it's the highest resolution image of Mars. It's got 1.8 billion pixels, I believe. So I just took a screenshot instead of me zooming on some parts, but make sure you go have a look. Like, it's just amazing the details we can see at the surface of another planet. And I completely missed your Van Gogh joke, Lawrence. Now I get it. And you can see there, if we zoom more on towards the mountains, you can see there's sort of a crater over there far in the distance. And you can see it's similar again to a desert on Earth, or in the Martian, the movie, like it's similar landscape. So you could have, I think, very interesting discussions, even just studying the movie The Martian. Where was it filmed? How do we know if it's accurate to Mars or not? And with pictures like that, you can get a pretty good idea. So anyway, I just wanted to highlight a bit some of those details, but it's pretty fun. Go check out this picture when I send you the link. Another probe that was sent from NASA, which you can still go on the website, is basically, it gives you the weather, or the temperature at least, on Mars. So if you go to that site here, last time I checked, the value, the data was from August 15th, but it was, you know, on that day, we got a high of -16 Celsius and a low of -94. And you can see like the week before, the highs were around -19, -18, and the lows were, you know, -90 something. But it's interesting to see the weather on Mars, and you could check throughout the year if it changes a lot. Mars does have seasons, so that could be something you investigate with your students. You know, once a week or once a month, you go get the value of that, where the lander is. This lander is on Mars, and you check over the year how it varies. Okay, so I put more links here with Curiosity and Mars, but again, we'll talk more about Mars in our next webinar in October. Okay, I have a few more slides to show you. Like I say, I'm already over the hour. I see many of you are still there. Thank you for being with me. I guess I had a lot to say about the solar system, but I should have cut more. Maybe not. Anyway, thanks for being there. I wanted to highlight the Cassini-Huygens probe that went to Saturn because it took some amazing pictures. So the probe was active between 2004 and 2017. Cassini, the main probe, was from NASA, but it had the small Huygens probe from the European Space Agency, which landed on Titan. And look at some of the pictures that it took. It's just so beautiful. And again, these are views we can't get from Earth. You can see you know, the rings here, and the sun would be lit on that side. And you can see this, so the sun would be from on this side, and you can see the shadow of the rings on the planet and the shadow of the planet on the rings. So it's, again, very, very interesting. You can see here, this is a picture where the rings, you can see them from the side. They're basically flat, like it's extremely thin. It's just a few tens of meters of, thick, actually. So, but the trick of light and shadows on this one, you can imagine the sun being on this side far away. So the rings are seen from the side. We can see the shadow of the rings, and there's a moon there. So it's pretty, I love this picture as well. The moon is Titan and Dione. I'm not sure exactly how to pronounce it, I must admit, in front of Saturn and its rings, and you can see the haze around Titan. So this is the moon with an atmosphere. And again, the rings are here. This is Saturn, rings, and shadow of the rings. So it's a pretty neat picture as well. This is one of my favorite pictures from the Cassini mission. So we're seeing the rings from above. So this is sort of a, you know, the flatness of the rings. And they're pretty thin, like I said, a few tens of meters. But some areas will show vertical structures. So the way the sun is oriented, again, trick of light and shadows, you can see shadows here from this part, and you can see the vertical structures. Apparently, some of that structure here is over 2 kilometers high, when the rest of the rings are only maybe 10 or 20 meters thick. So it is pretty interesting to see that. And again, just because the way the light hits that part, you can see that structure. Here we can see, again, in the rings, a bit of a similar view. This is a small moon here called Daphnis. It's only 8 kilometers across, but it causes gravitational perturbations in the rings, or disturbances in the rings. And you can see, again, it has some vertical structures because it's creating shadows. So you can zoom in on that one. It's pretty neat. Oh, yes, and before I give you the links for all that, this is the Earth as seen from Cassini. So I think there's great value in seeing the Earth from far away. You can see here the dark side of Saturn, so the part that's not lit from the sun. So the sun would be on the other side. The rings here, and there's the Earth. There's us. You know, and there's always a lot of value in that because you can see that everything's happening on Earth. That's what it looks like from far away. Or the fact that we're all, I love with internet right now, I'm talking to people in many different countries, but on that scale, it doesn't really matter. We're all on the same pixel. So that's pretty fun. So some of the best images, the ones I showed you, came from that long link in the middle there. But you can check some of the pages, again, NASA page and Wikipedia, and it has many, many more beautiful pictures. And the part I want to finish with, so I see someone here sort of, I see my teaching strategy, so students like unknown things, and maybe some of the things that are, to me, it's what's important as well, that's things that are interesting in the solar system that we often forget because we just focus on the planets, the sun and the planets, and there's a lot more. But another thing I find very important when teaching the solar system is to have an accurate representation of the solar system. And you can look at all three images here as I take a sip of water. And none of these are accurate. There's no way to represent the solar system to scale on a slide, on an image, or a sheet of paper. This one shows the planets to scale in sizes, but obviously not in distances, and they're not all in a line. Sometimes students will have the impression that the planets are always in a line. And here, this one, what I like about this one, that it includes the dwarf planets as well. So these are part of the Kuiper belt series as part of the asteroid belt. If we put the orbits to scale, then we don't see the objects because the objects are too small. And for very young kids, some of them might feel like those lines exist in space when they don't. It's just the path that the planets take, right? This image I've used because there's no perfect representation. So I like that one because it shows a bit, it's not perfect either to scale on the sizes or distances, but kind of shows you the different objects around the sun. But because it's impossible to represent the size of the planets and their orbits, we need to make models. And you can watch, I presented a webinar called Model the Solar System. I don't remember when, it was a while ago, but you can find it in our archives. So you can watch the whole webinar again, or you can just download the PowerPoint and see the activities I highlight. But I'll show you a few here. So I have about 5 minutes left. Again, thanks for staying there. If you have to go, you could always go back to watch this part. I think there's a lot of value. It's very rich to try to recreate a solar system to scale with respect to size and distances. So you can find objects of various sizes and place them at the right distance. But if you want to be able to see the objects, you have to be ready to take a long walk. So there are different options to do it, but I think it's a great way to get students outside as well. Teaching astronomy outside, making scale models around the school, or you can go for a walk on not so far from the school and so on. There are different ways to do it. You can choose the size for the sun, and then if your students are old enough, they can do the math themselves. A very good way to include calculations about proportions. If you want them to become familiar with the spreadsheet, or I put Excel spreadsheet, it would be Google Sheets, obviously, but have them write the calculation and then maybe create a form in the sense that you enter the size of the sun and it will calculate the size of the other planets in your model accordingly, and the distances from the sun. So there's a lot that could be done there, and I'm just kind of throwing ideas. The level for your students, and where you might be able to go with that. If you don't want to do the math, we have a calculator on our website, which I'll show you in a minute, where you just enter the size of the sun and it makes the calculations. And there's an activity from the planetarium. This is the planetarium in Montreal, where they have made the calculations, and I don't remember the size of the sun exactly. I believe it's like a basketball, but then the Kuiper belt of Pluto would be about 1 kilometer away. So that's, that's in your neighborhood. You can walk that distance. If you go to our website, this is you need to select the size from the sun. So you either enter the diameter in millimeters directly, the value you want, or you can choose a size from our drop-down menu, and we've put different objects there. So in this case, in this example, I picked the exercise ball, and then it calculates all the other values automatically. So it will give me the size of the object. So if the sun was an exercise ball, the Earth would be 7 millimeters across. Oh, and this is, so it's like, the kernel of the popcorn. So it kind of gives you a size of an object similar to that, close to that size. And it gives you how far it would need to be put. So again, the sun is an exercise ball. The Earth is just a corn, and you have to put it 86 meters away. So that's kind of gives you a sense of scale, and usually it's bigger than what we expect. And on our website, if you want, you can even map it on a Google map. So you click here, this is the city I live in, Tetra Mines. I clicked on the high school, and it puts the orbits. And the way I'm zoomed out, actually, I see violet, brown is Jupiter. So Jupiter is right here. So I see the outer solar system, but I could see the inner solar system much closer. I would not be able to walk that distance because I have to go I mean, Neptune is 2.6 kilometers away. The Kuiper Belt or Pluto would be like 3.4. So it would be pretty far, but you could scale the model depending on how you want it. There are some activities, and I look forward to doing this one that's in an in-person workshop one day when we can start doing those again. You keep the distances right, but not the size of the objects, but you also put the directions. And there are ways to do it. You can look online for like the angle of where the planets are today, and you can make a model of the solar system today. And from that, there are ways to go and find out when and where the planets will be visible from Earth. I won't go in more detail, but you can see that link there. This is a site page from NASA. And I've done something similar before on paper, but I love the idea of doing it outside, especially now with COVID. If you can bring your classroom outside and do an activity outside, I think it's a very good time to do it. And this is a fun activity. You could also create just a model of the size of the objects, not so much the distances, but just the size of the objects. As you can see from that image, it is pretty impressive to see how small the Earth is compared to Jupiter, for example. You can use various objects or Play-Doh. The activity that's there is using Play-Doh, and I love it. It's a very interesting activity to do as well, because you realize, if you start with a big chunk of Play-Doh, most of it will end up in Jupiter and then Saturn, and then you're just left with leftovers with the smaller planets. It's pretty impressive. So there are various resources. You might have seen this video. It was it went viral, I think, for a while on social media. Solar System to Scale, a team which created the scale model of the solar system in the desert in the United States. And it's very well done, but I still think there's a lot of value in doing it with your students directly as well, or have them calculate or walk the distances. There's more to it. They will remember it more than if they just watch it online. And I just want to mention that Astro at Home was the initiative we did last spring when schools closed because of the pandemic. We had daily episodes on different subjects for kids directly. Our target age was 8 to 12, but I think some of them would be a bit advanced for 8 years old, and some of them, anyway, you can adapt a little bit. Many of them are linked to the solar system, so you can go check that link there and just browse through the different titles and find one that you find interesting. You could show parts of it to your students as well. For example, there's one about gravity in orbits, which I presented that I didn't cover much here, but that could help you understand sort of big structure of the solar system and why it works that way in the orbits and so on. And the episode from March 18th was an introduction to Stellarium. So if you want to learn how to use it, of course, the sky won't be the same now, but Mike, my colleague, shows you how to use the software if you are interested. And I want to finish with some important points that you might have guessed from my talk so far. The solar system is bigger than you imagined, so it's really worth doing a scale model. I think the pictures that we see, the representations on paper or on a slide or on an image, don't give us a good idea of how big it is, so it's really worth doing a scale model. The solar system is much more than the sun and the planets. I think by now you probably understand that point. Some overlooked objects are the most interesting. And the solar system objects are beautiful and varied. I mean, there's diverse surfaces, icy worlds, extreme weather, and it's kind of fun to compare those and highlight those. So there you go. Thank you very much for staying until the end. I guess I talked for a while because I was planning on doing that within an hour, but I guess I gave you many, many details. If you have questions, the info you see there, the info@discovertheuniverse.ca, that email address comes to me directly. So that's how you can reach me. We're also on social media, and you can see the both languages here, English and French. If you are not on our newsletter, maybe make sure to subscribe to our newsletter so you know what's happening if you are interested in learning more about our upcoming resources. We have many projects in the background. They're not showing on the website yet, but we're working on many things. So we want to let you know as soon as they're ready. And again, for those of you who are online, I'm kind of talking here, giving you time to write questions. But if you have questions, please let me know. I'm happy to answer. And thanks for staying till the end. See, there's quite a few of you still here. Oh, there's a few names I know here. Hi, Jim. Hi, Ed. I will send you the links. It takes a while to get the recording from Zoom, but as soon as I have it, it might wait till tomorrow morning for me. But yeah, as soon as I have everything, I will send an email to all participants. And I'm just gonna wait again, see if there are some questions. I'm happy to take them. If some of you would like to turn on your microphone to ask a question, this is something that could be done as well. Let me know. I will stop the recording here because I don't see any questions coming in right now. Maybe they're typing, but thanks. If you watched the recording till the end, thanks a lot.